I'd like to take a couple of minutes to talk about lines of best fit for scatter plots. And the first and most obvious point is that they don't pass through all your data points, or probably even any of your data points. And that's alright, don't worry about it. The second thing I'd like to say is it could be a straight line or a curve. And those are both alright. And as such, it can be described by an equation. So you know already how to describe it, just a straight line with an equation, but more complicated curvy lines can also be described by higher order equations. Let's talk about the slopes. So if we've got a positive slope, so that's a graph that looks like this. So as x goes up, so does y. Then we call that a positive correlation between the two variables. Whereas if we've got a negative slope, which is to say a graph that looks like that, that's a negative correlation. A couple of tips for drawing lines of best fit by hand. So first of all, I think it's important to try and get half of the data points on either side of the line, as I did on the previous video. And the second thing to say is a word of warning not to be too distracted by extreme values at the ends of your data set. So don't pay too much attention to extreme outlying values. So, for example, if we've got lots of nicely grouped together and then the last value is all the way up here, then you don't put your line to be like this. You'd concentrate more on these, probably do something like that. One last thing to say, so if you're drawing a graph on a computer, then the computer will calculate the line of best fit using a method calculates using a method called regression. So that's an algorithm where the computer works out and optimizes the distance of the line, taking all the different points into account together. So I just wanted you to hear that word, regression. So those are just some things I had to say about lines of best fit for scatter plots.